solar charge controller or mppt solar charge controller, which one is the best? So it's like you guys are not tired of this topic, because I don't know, I've explained before, a lot of YouTubers or TikTokers have also explained, and like you guys are not getting. So I'm going to break it down into two parts. One is the voltage range, then two, the quality of the material. So the first one, basically, if you want a PWM solar charge controller to produce its peak, I mean to generate the peak energy it's receiving from the sun and give it to you directly the way it is getting it from the sun, you need to get a solar panel that is close to the voltage range. So say for example, you are setting up a 24-volt inverter system, which means you have two batteries connected in series. Now you want to, now let me write that again, 24-volt inverter system. So you want to get a solar panel that has an open voltage of around 32 volts and a closed voltage of around, say, 28 volts, which is very close to the battery full of a 24-volt inverter system, which is 28 volts. So if you get a solar panel around this voltage specification, you would actually maximize a PWM solar charge controller, which means it's not as if your PWM solar charge controller is not going to perform very well when compared to an mppt solar charge controller. But there are instances, there are situations that have to come in place before you would actually be able to get the best out of a PWM solar charge controller. But an mppt solar charge controller, on the other hand, you have high voltage panels, you have low voltage panels, it's still going to work just fine. It's going to find the maximum power point tracking. It's going to give you the best that it is generating currently. So, but they usually work best with high voltage solar panels. So if you have a high voltage solar panel, like a 48-volt system, 48-volt solar panel, it is actually going to convert the excess voltage to current for you, which is one of the unique features of an mppt solar charge controller compared to a PWM. So a PWM, if it sees a 48-volt solar voltage coming from your solar panel, it's actually going to take only what it needs to charge your battery to 28 volts, which is this operating voltage for the system. It's only going to take probably from, it's going to take only 28 volts, and once it takes that 28 volts, the excess on it is going to be a loss for you. So let's say you have about 30% loss when using a PWM solar charge controller versus when using an mppt solar charge controller. Now, on the other hand,